Welcome to the last video of 6.1 Concepts of Oxidation and Reduction lecture videos. In this video, I will be going through an example on balancing half equations to start with and combine them to write a chemical equation, overall chemical, redox equation, that is. All right. So here is the context. So in this example, I would like you to write two balanced half redox equations and combine those two later on to write the overall redox chemical equation. Context is a solution of permanganate ion, which is MnO4 minus, is used to oxidize iron 2 plus into iron 3 plus. The permanganate ion is reduced to manganese 2 plus ions. Now, reduction is something that you can see as MnO4 minus that became Mn2 plus, and Fe2 plus is now becoming Fe3 plus. Now that's where you start. These two half equations are not balanced. So the first job for you is to balance them. Now, it is important for you to probably know that potassium manganate, KMnO4, is a solid salt that's often used to make this solution of permanganate solution. Its color is purple, like what's shown around here. The original color is purple. And then once it's reduced, its color changes to yellow. So yeah, you can see the oxidation number changes quite readily. I'll probably do a demo on that in class. Anyway, this reduction half equation is something that would pop up fairly often, so it's worth even memorizing or just being familiar with the numbers of things that's going to be included. Anyway, let's balance them by using Mr. Cohes. Alright, so reduction is MnO4. I suggest you to provide a lot of gap and then an arrow, then the product. Do the same for oxidation reaction. This is because you might be adding water or hydrogen, electrons. You never know where you would be putting them. So, yeah, let's leave some gaps, and yeah, hopefully you have enough gap for yourself. All right, here we go. Now, Mr. Cohes stands for key atoms. Now, let's look at the reduction here. Mn is not oxygen or hydrogen. There's one atom each on one side, each side. So you don't need to do any balancing for K. Or oxygen, yes, there are 4 oxygen atoms here, but there's none. You need to add water to balance number of oxygen. Water is present in the solution, so it doesn't matter as long as you add them. So 4 oxygen molecules are involved. K, O, and H is next. Cohes, so yeah, H. How many are there here? 4 times 2, that's 8. 8 atoms need to be added. But in the form of ion. So it needs to be hydrogen ion. 8 H pluses. Cohes, so that's E there. Electrons need to be added to balance the charge. All right, you need to look at, I might actually move this down later. You need to look at the the charges of both sides, and then decide the number of electrons required on each side. More positive side requires more negativity to balance the charge. Right, MnO4 minus is as a whole -1, and there are 8 lots of charges there. So overall, on this reactant side, there are positive 7 charge. How about on the product side? There are 2 plus charges here, and H2O has got no charge as a molecule. Therefore, it's 0. So as a whole product side, there is a charge of positive 2. What's the difference? Well, you need to make more positive side matched up with less positive side with by adding electrons. You would probably need 5 negativities on here. So that's what I would be a bit of out of space. 5e minuses. Okay, let's check the charges. So -1, 8 plus, and 5e minus. If you add them up together, you should still get 2 plus. So now it's balanced. So that's 1/2 equation done, except for S for states. We'll worry about it when we combine. Let's look at oxidation part of it. What was it? Fe2 plus, a lot of gap, and it became Fe3 plus. Let's follow core hairs. K, 1 to 1, so that's done. O, oxygen, that's not involved, so forget about it. H for hydrogen, there's no involvement of water, so no hydrogen as well. E, well, the charges are not balanced, is there? So let's balance that. This side is 2 plus, this side is 3 plus. So 3 plus would need 1 electron to balance the charge. Now, reactant side is 2 plus, and product side is also 2 plus as a whole. Yeah. Okay. Now, so you have got balanced half equation for reduction and oxidation separately. All right. Next step, you need to combine them together. How do you combine? Well, you need to balance the number of electrons first. Five electrons are involved in redox, but 1 electron is involved in oxidation. So what you have to do is to multiply the whole thing, oxidation half equation to match up with 5. Times by 5. Yeah. What it means is that you would get 5 in front of Fe2 plus and 5 in front of Fe3 plus and 5e minuses at the end before you combine. All right. Let's then combine overall. All right. Basically, you write on everything you see on the left-hand side, and what you see on the right-hand side, except for electrons, because they would be canceling out. That's the point of you multiplying this half equation. So, MnO4 minus plus 8H plus no electron, jump to here. And remember, you also multiplied that by 5, so 5Fe2 plus. That becomes Mn2 plus 4H2O plus, you multiplied this by 5, didn't you? Sorry, plus 5Fe, can you see it? Yeah, just maybe. Plus 5Fe3 plus. It's a bit weird like that, but that's the reactant, and yeah, these 3 species are the products in this case. Now, these products here, well, the reactants and products should have the same charge as well. So let's again count them. So there are what? -1 plus +8 plus 5 times by 2, which is 10. That would equal to 18 take 1, so yeah, 17 positive. Sorry about the color here. Positive 17 is on the reactant side, and the product side. What do we see? So 2 plus here. I'm gonna just write it here. Positive 2 plus 4 times by 0, so that's 0, and 5 times by 3, so plus 15. Also equals to positive 17. So as long as they match, you've done the right thing. You have balanced, you have written a balanced redox equation.